Hi folks, welcome to another What's Behind the Curtain in Neon District. We'd like to show you the start of game loop and the power of grid. The game loop's pretty standard in that you got your loading, your main menu, your playable, loot, and then credits. A pivotal system in grid is an event bus. An event bus is something that lets arbitrary systems talk to each other, and in this case, our preloader talks right to our scene GUI. We added some fancy little things like fading and transitioning between scenes, which we'll talk about later. And in this case, after dealing with our opponent, the panel manager's been told by the event bus to load up its victory panel. The player's click goes through the grid's gameplay event bus to signal all of its subscribers that the player wants to go pick up some loot. Once the loot's been picked up, it's gold baby, ship it, so it's time to roll credits. Shortest game ever. Well, there's a lot more going on underneath the hood, which we'll go into later. For now, just know that we're on the precipice of a lot of great gameplay, and to stay tuned for feature after feature after feature, sneak peeks and heavy graphics coming your way. Now it's time to warm up for what makes grid good. The credits is a great example of a grid-ran system scene. As hinted at earlier, the grid is responsible for how the scenes flow together, managing all the features, the events, the timings, and being able to snap on other features quickly. And here is the grid at its humble top level, showing off its features and the features options with an ability to generate more features. It's so easy to make new features that I just couldn't help myself but to drop a conversation system into the game. So here you see me filling out some nodes and making some quick dialogue for a nice little prelude cinematic. What usually happens when you start sticking features together from unknown code sources is that the code becomes, quote, spaghettified and then quickly unmanageable at a exponential rate. But the grid system, with its encapsulation enforcement, is immune to that. You'll notice that grid is running the scene directly instead of as a normal part of gameplay, and this helps out designers test out their creations really fast. And as we expect here in the scene, here's our dialogue appearing above the proper NPC's head, and we go to fight. So don't tell management that making a new feature is this easy, otherwise they're going to come at me with a huge grocery list of things to build. From here, we'll talk about the art pipeline and to what it takes for getting one of these characters into the game. Here we've got Photoshop with each character in its male and female version layered in a specific way and coded so that a script can export into a myriad of different images. Now after the export from Photoshop, we go to Spine, where each one of these images can be added to the base character. We make a standardized set of animations per character posture, basically like what kind of weapon or item does the character hold while they're doing whatever standard operations. Then we export this character base set to Unity. We've constructed some tools to help us out importing all these crazy amounts of images that are the result of the Photoshop and Spine combination. Here we're showing a corrective measure in that one image in particular is being analyzed. But wait, when there's thousands of images, wouldn't it be nice to have a batch operation to just import a lot of them at one time? Well, wish no further, here it is. Each one of those thousands of images needs to be optimized, separated, and organized, put into recipes, made into thumbnails, etc. And that one piece of batch is able to save literally hundreds of hours of import time. Batch processing also means that the characters can have very complex reactions to different kinds of combat contexts. When a player buys one of those $500 Elite NFTs, their supergun does some super stuff. Built into all this, the artists need a way to test things. So here we have an example of one of our characters having freshly loaded supplies, and we change some data, reload him, and we display him again using a different kind of item on his head, and voila! Now he's got different stuff. You'll notice that all this takes place in the editor, so you don't even have to load a level for an artist to test out their things. This is very important to all the tools that we use so that designers and artists alike can have a visual of what they're doing as they're doing it and as they're creating it. One of the new cool tools of Unity is using timelines. This is a straightforward way for both designers and artists to test out their assets in live time. For an artist to work quickly, they need to be able to see the results of their work right now. Here we see the stage putting together all the artist's assets in live simulated action. The stages are also timeline activated so that they can tell the actors where to go, what to do, what to say. Oh, don't tell management about that one because that's our secret, remember? The stage is a 3D stage, so we can do things like parallaxing and having different kinds of camera angles, and it doesn't have to be on a two-dimensional background either, so we can have lots of fun with that later. The modularity of the stages is greatly enforced here so that every stage can have sub-stages that attach to it, and here we show a visual effect having a stage all by itself. Artists are frequently challenged by trying to combine various aspects of multimedia from audio, sprites, particles, models, etc. And here, notice the nonlinear nature of how we intuitively got things together for the artist, and also to test things at editor lifetime. Artists can also make their visual effects context aware so that they know about the actors which they join to. This way, muzzle flashes and chest impacts can have varieties of different kinds of effects based off of what kind of combat's taking place at the time. The command architecture makes sure that the artist is no longer bottlenecked at the programmer. So if you're a businessman or an artist, thanks for joining us, but if you're an engineer, we've got some fun stuff to talk about now. Grid is basically a platform to which supports features for games. This makes the whole thing a white label game system. Because of the code base, the demo that we started with at the beginning of the video took only a day to implement. The modules encapsulate people's code so that they don't spider out. What normally happens when these kind of safety features are not implemented is that code spiders together and makes things exponentially harder to debug. And then before you know it, what should be taking days costs you weeks and months. By comprehensively regulating the events and updates of the modules, each one of these features becomes their own little island. New feature? No problem. The manage mono behavior is one of the things that snap into place that accepts grid's events and contextual updates. Things like pausing is handled in the grid, so the update function of the mono behavior here just doesn't update when the game is paused. The event manager is the absolute core of how this thing works so that things can talk to each other without knowing about each other. Grid takes care of update timing, and while the event manager takes care of fire and forget game events. Everybody ships around their little picnic basket of data, and when it finally gets to the destination, they know how to use it. And my favorite part is the events that the game can throw. Here, adding another game event is just adding another entry to this enum list with a quick explanation of where it goes and what it does. Debugging couldn't be simpler.